Okay, folks, welcome to our last session. Kind of exciting because this is our last actual lesson. And so, what I'm going to do is two things in one, just to be efficient here. We're going to talk about finding the volume of some shapes in the volume. And then we will also do a quick review for your last test because what I want you to do is go ahead and just use your last notes and homework from the last lesson or two to help you prepare for the test. But also, I'll give you some other tips here in a moment. All right, finding the volume practice. So we're just practicing this with some more story problems. Okay. So hopefully you freeze the screen, you copy down what you see on the screen, do your best to try to draw the pictures. And the first thing I'm going to mention here is that this page right here in your book, page 137, it's got all the formulas that you need for both your homework, for your unit test, the fourth test. So that's kind of a real important. You might want to take a post-it note or something and stick it in your book on page 137, and maybe with a little some words on the post-it note that say formulas. Okay, so we got a sample question here. A cylindrical water tower is half full of water. Okay, now I want to illustrate something. It says it's half full of water. Okay, so I'm going to draw a box around this because that's going to become important in our calculation. Okay, it's half full of water. How many cubic feet of water are in the tower if it measures 20 feet high and has a radius of 7 feet? Okay, so that's our question that we're answering here. So there's our tower, 20 feet tall from the top to the bottom here, and it's got 7 feet radius. And again, the radius is the distance to the middle. Okay. So again, I've modeled this for you. Take your formula, which you'll see on page 137 for the volume of a cylinder. It'll say it's pi r squared h, which is 3.14 times what's my radius? 7. So 7 squared times the height, which is h, which is 20. And so that's 3.1. Where did I get to? Oh, 307.72 cubic feet. Okay. So, and remember, 7 squared is 7 times 7, which is 49. All right. So that's an example of how to find the volume of a water tower, or in this case, a cylindrical shape. All right. Let's jump to our next shape here. And what I want to do is talk about in my next slide here, talk about kind of a sample question that you might run into, and that is how many cubic yards of sand will it take to fill a child's play area that measures 10 yards long, 8 yards wide, and 1/3 of a yard deep? Okay. So there's my drawing here on the right. It's my children's play area. Think of it as a sandbox. Okay, it's a box full of sand, and want to know how many cubic yards you need of sand you need to get at Lowe's or at Home Depot. Okay, so again, we've modeled the formula here on the right here. The formula of volume of a rectangular solid is length times width times height, LWH. Okay, so that's 10. It's 10 yards long. Okay, from the length of the shape is 10 yards by width is 8 times 1/3. And if you punch that into your calculator, you'll get 26.4 cubic yards. However, I want to go back to the number 1/3 there. You're probably wondering, some might be wondering, how do I make that into a calculator, punch that and just go 0.33, and that's 1/3 of 100. So 0.33 is the same as 1/3. All right. All right, let's move on to our next slide here and talk about a two-step volume problems. Okay. Two-step volume problems, and you've got some in the next couple of pages of your textbook that I want you to take on. Two-step volume problems, and go ahead and freeze the screen here for a moment, and I'm going to pause this recording. And okay, hopefully you've copied down what's on the screen. It's a little complicated, but we're going to talk about what's going on here. two-step problems. What's the volume of the figure to the right here? So we've got this figure that's this shape here. But you'll notice it's actually two rectangles. One of them is the big, call it a big block. And then there's a block on top of that block. And what would be the volume of the total figure, okay, of this thing? So I want you to think of dividing it into two separate shapes, okay? And that's really important. Block one and block two. We're going to find the volume of each block. So if you look up here at the top right of my screen here, you'll see that I've got the volume formula, LWH, length times width times height. And the very top block has a length of 4 feet, as you can kind of see at the top here of this block here. It has a height of 3 feet, and it has a depth of, and my illustration isn't the best here, but I want you to imagine that this block goes all the way back to here. Okay, so it goes from here to here. So if I look down here at the bottom of my big block, I'll see that it's actually 2 feet all the way across there in its width. So length times width times height, but it's two. I want you to imagine it's 2 feet all the way across there. Okay, so if you find out the volume of this first shape here, okay, that's 4 feet by 3 feet tall. Okay, and here's my 3 feet over here. I'm drawing an arrow towards it, times a depth of 2 feet. Okay, that gives me 24 feet. All right, so this first block here is 24 cubic feet. All right, let's find out the volume of the second one. Again, I've written down here, I'm going to put a box around it. Here's my formula, okay, and I plug in my numbers. The length is 9 feet. You'll see that at the bottom of the big cube. The width is, the height of it is 7 feet, and then the width of it, depth of it is 2 feet, okay? So that gives me 126 cubic feet. So I've got an answer. I'm going to circle at the top of the first shape is 24, and the other one's 126. If you add those two together, as you'll see here to the left here, 126 plus 24 gives me 150 cubic feet of space, okay? So again, the key to this one, as I mentioned earlier, is to separate the shapes into separate shapes so that you then find the volume of them separately and then add them together, or in some cases, you're going to subtract them, okay? So let's take a look at another example of adding shapes here. I've got my mailbox here on the screen. Sample problem, what's the volume of this mailbox? Okay, and so you have to kind of look kind of carefully. I want you to imagine that the top half of my mailbox here is rounded, right? That is like a half of a cylinder. Okay. We're going to consider it half of a cylinder. Remember, a cylinder is like a can of pop, like a round, long subject that has length, width, and height. All right. So, but imagine that the top of this mailbox, if it's like you cut a cylinder, a can of pop that was laying down, you cut it in half, okay, laying on the table, and you cut it the top half of it off all the way across. That's kind of what I'm illustrating when I say this right here at the top left here. Half the cylinder plus the rectangular solid is what we're going to find out. We're going to do this problem here, and then we're going to add, this is our two-step, we're going to add our solid rectangle to it, and that'll give us the total volume of this structure, okay? Or in this case, it's a mailbox, all right? So the first thing I'm going to do is I'm going to take my cylinder formula, and so that's what's in the bottom left, and I rewrote it out. Volume of a cylinder is pi r squared times h, where pi is 3.14 and r is the radius, okay? So the radius of this one is 4 inches. You'll notice that at the top of my diagram here, I'm kind of drawing an arrow towards it now. That's 4 inches from the top to the bottom, or across the this can of pop, half of can of pop, which we're calling the top of our mailbox, okay? So if I do pi 3.14 times 4 squared times 20, now you might wonder, where did this 20 come from? That's the length. If you look here, if I draw my arrow on the top right, that's the length of the whole thing, okay? Or in this case, it becomes kind of like the height. It's like a can of pop that's laying down on a table. If you set it up so it's standing straight up and down, it would be 20 inches, okay? All right, so if I take that 3.14 times 4 squared times 20, I'm going to get 104 or 1004.8. Okay. And that's cubic inches. However, I want to go back up to the top left of the screen where we're going to take half of that. Why are we taking half of that? Because we just found the volume if it was a whole cylinder, but we've only got the lid of it, the top half of it in our mailbox. So if you punched in your calculator one half, which in this case, just use 0.5 on your calculator, times our 1004.8, you get 502.4. Okay. So that means the top section, the rounded section, all the way across or down or through my mailbox, like I sliced the top off, is 502.4. All right. Now, step two, okay, I'm going to find out the rectangle. And so if you can see, imagine the rectangle, like the top's cut off. So I've just got a box there, okay? And the volume of a rectangular solid is LWH, length times width times height. So plug in my numbers. It's 20 inches long, it's 8 inches wide, and it's got a 5-inch depth to it. Okay, or 5 inches tall and 8 inches wide. Okay, plug those numbers in, you get 800. Now, if you take and you add together 800, which is the total box without the lid, the top little rounded part, plus my 502.4, I get 1302.4 cubic. Okay. This would be cubic, CUI inches, because it's inches. Okay. So that's a little bit complicated. You can slow this down, watch it again if you need to, but you're basically on these two-step problems, you're cutting your shapes into two separate shapes and then solve each one of them separately. All right. Now let me take an example next here where you're dealing with all right, you can freeze the screen, copy this down, and come back to me. But what I want to do is talk about, I want you to imagine my shape here. I don't know if we could, what we can illustrate this as. Maybe it's a block of cheese, okay? And somebody wanted a cheese stick. So they took a special tool and they cut out of the middle of this block of cheese another little block, okay? And so I'm going to draw an arrow here towards it. This is it's cut out of the cheese all the way through the cheese, a little block of cheese. Okay. And it's 3 inches by 4 inches in length times width. And going all the way through the block of cheese, you'll see that it's 10 inches if you look on the far right here in depth. Okay. So how many cubic inches of metal are contained? So if in this case, it's a metal container and it's got a hole going through the middle of it that is a square hole or rectangular hole, excuse me. And so what we're going to do is we're going to find the total of the whole thing, the whole metal block. So our formula for a rectangular solid over here is the top right here. There's our formula. We wrote it out, LWH, 6 times 10 times 5. Those numbers come from the actual big shape. If you look and see, that gives us 300 square inches of volume. However, we've got a hole going through the middle of it, okay? And the whole of that one, this is my second one here. My second, I've rewritten the formula. Volume is LWH. That hole we cut out of the cheese, so we could have a smaller cheese stick, or in this case, out of the metal block, was 4 inches by 3 inches by 10 inches. Okay. And if you're wondering again where that 10 came from, if you're looking at this thing here, it's 3 inches tall, 4 inches wide, and then the depth of the whole thing over here on the far right here is 10 inches. Okay. And because that goes all the way through, it's like it goes all the way through this kind of imaginary line here that I'm drawing here. Okay. And so plug that in, that gives me 120 cubic inches. I'm going to take that slice out of the middle and subtract it. So what I'm doing is illustrating in kind of color here at the bottom right. I'm going to take that slice. So I got my 300 total block of metal. That's the answer I got up here. Okay. I got 300 total. Okay. Wrote it down. And then I'm going to subtract my 120 cubic inches. That's the hole out of the metal. And I illustrated this. If you did the long way out of color, you'd get 170 cubic inches of metal in this case, because we're calling this thing How many cubic inches of metal are contained in this hollow rectangular bar below? And that should say bar. Okay, so this is a bar. All right, going to go on to our next slide here and talk about another type of a problem. Getting kind of fancy here, okay, with our shapes, but I know this might look complicated, but again, I want to just say to you, two steps. Remember, two steps. Okay, so you're going to find the volume of metal in the tube below. So I've got my fancy tube here on the screen here, and you'll notice that it's 14 inches long. Okay, and that's going to apply to the hole out of the middle of it. And it is 8 inches in wide, and it is so it's 14 by 8, the big tube is, and then there's a smaller tube cut out of the middle of it, as I have illustrated here, that is 6 feet in diameter. Okay, 6 feet from here to here. Okay, so that's 6 feet, and that's cut out of this metal tube. So find the volume of metal in this tube. Well, it's got quite a bit cut out of it, right? So the volume of metal is the amount of metal that it is actually there is here. So I've written my formula. The volume is pi r squared times the height. Okay. And in this case, I'm going to plug 3.14 in times 4 squared. Okay. Now you're probably wondering, where did that 4 come from in that formula? Look at the diameter of this whole thing. Okay, all the way across this thing, all the way across. I'm drawing this here. That is 8. That is 8 feet, and I get that 8 because it's over here. I've kind of illustrated it right here. It's 8 feet all the way from top to bottom, or going all the way across it. Remember, r is the radius, and the radius is half of the diameter. Okay, so that's where that 4 came from. It's half of 8 times the height. Plug in our numbers, 3.14 times 16. 4 times 4 is 16. We've 4 squared times 14. Where did the 14 come from? If we're standing this tube up on a table, it's 14 feet tall. Okay, you can see that at the bottom of the diagram. Okay, so I plug those numbers into my calculator, and I'm going to get 703.32 cubic feet. All right, that's the whole shape. That's the whole thing. I started with a big thing first, okay? And then I got a smaller shape, so I'm going to go back to my formula again and calculate the smaller shape that's cut out of it. V equals pi r squared h, 3.4 times, I got 3 squared here. Where'd that 3 come from? Let's go back to the diameter of the smaller shape. I'm going to draw an arrow towards it. I'm going to go like this, okay? This right here is the diameter of the smaller shape, and you'll see it's 6 feet all the way across that hole. Well, radius is half, so that's where the 3 came from. Okay. So 3.14 times 3 squared times 14. Where did the 14? That's the whole length of the whole thing. That hole goes all the way through the whole cylinder. Okay. All right. In this case, I'm going to do all that math and get 395.64. Now, final step is to take the total volume of the whole cylinder. Okay. And that's 703.32, and that's what we got from our first calculation. Subtract our whole, which is our 395.64, and I should get 307.68. Okay, so I guess I have room over here to write this, but 0.68. All right. Why does that feel wrong to me? Oh, we're subtracting. Sorry. Yeah, we're going to subtract. So make sure that you subtract there. Okay. And that would give you 307.68. All right. I'm going to go on to my next slide and talk about, let's see here. Yeah. Let's see. Okay. Now I'm going to review for your last test, and there's only like 2 slides here, because what we've been doing in the last day's lesson, is prepping for it by figuring out the volume of shapes. Okay, so what I did is I listed like 4 bullet points. Okay, and if you review these 4 things, then you're ready for this last fourth final test. Okay. And I want you to remember and remind you that you need to keep your percentage at 73% or better in the class. That's what the transitional studies determines you've learned the content. Okay. So we want to do well on this last test. Okay. We're aiming in the 90s. Okay. All right. Point number one, be ready to identify the shapes. Okay. So if you see a shapes on the screen and it says, what is this shape? You should be able to say it's either a cube, a rectangle, a solid, a rectangular solid, a cylinder, or D, a cone. All right. Know what those shapes are. Okay. And remember, the cone is like an ice cream cone or a party hat. All right. Number two, be able to match the formulas for volume with the shapes that they are for. Now, this is where there's that page that I mentioned earlier, and I've got my book right here. So I'm going to flip back to it, see if I can find it real fast. Yeah, it's page number 137 in your book. So this is where you want to have that page wide open, and then these questions will be a piece of cake. Okay. That just seems fair rather than expecting you to memorize all of these. But all of those formulas, length times width times height is a solid. The side cubed is your cube. Okay. And then et cetera, et cetera. So you've got the formula for the cylinder and for a cone. All right. We are just about there, folks. Last slide, and that is be able to find the volume of the shapes in this unit. And what that means is basically those formulas I just talked about. If it gives you a cube, be able to find, and it gives you numbers, be able to find the volume. And that's what you've been doing in the last 2 days, okay, of my lessons. So if it, whatever it is, whether it's a cube, a rectangular solid, or a cylinder, or a cone, you just have those formulas and be able to do that. All right. The last thing is to be able to find and solve, be able to find, be able to find, solve. All right. It should just be able to find the volume of two-step volume problems. Okay. Be able to solve those two-step volume problems. We've just been doing that. So if you do that, you will be ready. Now, before you go on, however, I want to give you some homework that I want you to do. So what I'm going to do is I'm going to put on the screen here. Okay. What I want to do is I want you to do the homework on page. Please don't try anything until you've done this, but I want you to do the homework on page 138. Just do the odds. Okay. 138 through, I'm kind of flipping through my book here, through 142. So 138 through 142. All right. That's your homework. And odds only. If you do that, you should be ready to roll on this test. If you've done all those homework problems, it'll be a review for the final and this final test, and it'll cover everything that you will need to know. As always, if you have questions, please be sure and ask me. And I think everybody's going to do fantastic, I hope. So good luck to you. And if you have any questions, send me an email. All right.